first of all, you should know what the graph of y is equal to square root of x looks like, and the square root graph is that right there. And what will the -1 will do to that graph? It will move it one step to the right, opposite direction. So this is the graph of that function. Okay, so that's the graph of that function. So what's the domain in the range? Well, the domain, we can state this in interval notation, is brackets, starts at 1, goes to positive infinity. And what is the range? Range of the y values, it starts at 0, because that's my y-axis, that's my x-axis, and it goes up. So that will be 0 to positive infinity. That's it. Okay, let's get to number 5. In number 5, they give us y is equal to square root of 25 minus x squared. Well, you know what? If this was just y is equal to the square root of 25 minus x will look like. It's a square root function. Okay, only thing is that by putting a square on that, you can also use negative numbers, whereas this function will only exist to the right, okay, or to the left, or you can only use negative numbers. So now you can use positive numbers also. So the square wasn't there, okay, then the only numbers you can use are the numbers to the that will give us a positive value inside that. Okay, that means 25 minus x has to be greater than or equal to 0. That means that x is less than, okay, or equal to 25. So those are the only numbers you would use if you just have the x. And but if you have an x squared, you'll have to solve 25 minus x squared has to be greater than or equal to 0. Then we would factor that, which would be 5 minus x, and then 5 plus x, which is the difference of two squares. And do number line analysis. And when you do number line analysis, you got a 0 here, you got a 5 here, and you have -5. Partition. Putting a 0 makes this into a negative, and then into a positive, so that's negatives will be positive and positive, so it has to be greater than 0. That means the graph only exists to the right of 5 and left of -5. So, what is this? This is still a square root function, and it will look like this. 5 to the right, and then -5 to the left. So you really get two of these. So y is equal to, that's y, and that's x-axis. Okay, so let's state the domain in the range. Well, domain is, let's state that in interval notation. So it's going to be negative infinity to -5, brackets, union, 5 to positive infinity, because it goes to the right. And then the range, it starts at 0 and goes up, so range is equal to 0 to positive infinity. And that's it. So that's what the graph of that function looks like. Okay, let's go to another section. And composite functions, section 6. So this is section 6. And let's look at number 3. They give us f of x is equal to x plus 1, and they give us g of x is equal to 1 over x. And what they want us to find is two composite functions, f of g and g of f. Well, this really means f of g of x, and this really means, okay, and this really means g of f of x. And then they want us to state the domain in the range. Okay, so in this one we're going to take g and we're going to put it into f. But before we put that in, we have to identify what the domain restrictions are. There is no domain restriction for here. I can use any number for x. But here, I know x cannot equal to 0. Okay, because that will make the bottom to 0. And if I'm putting g into f, this restriction has to stay. It doesn't go away. So let's go ahead and put it in. F of 1 over x now will look like 1 over x plus 1. Okay, so that's the f of g of x. Okay, so domain restriction is set of x's such that x is an element of all reals and x cannot equal to 0. And if you write this in interval notation, you can do that too. Negative infinity to 0, and then union 0 to positive infinity. Either way is fine. This way or this way is fine. Now, let's go the other one. We only did half of it, so we have to go the other way. So now we're going in this direction. We've got to check the domain restrictions. So that one doesn't have any domain restrictions, so we don't have to carry anything with us. But when you put this in here, you have g of x plus 1. That means we're going to put x plus 1 in g, so that's going to be 1 over x plus 1. Now this one has a new domain restriction that comes up with. That means x cannot equal to negative 1. Okay, so again, we can write the domain of this in two different ways. Set of x's such that x is an element of all reals and x is not equal to negative 1. Or you can write this as interval notation. Same thing. So you're going to go from negative infinity to negative 1 union. Okay, and that's negative 1 to positive infinity. Alright, so I want to go do two more problems. So let's go to section 7. So we have section 7, and that is, I'm going to do number 3, and f of x is equal to x times 4 minus x squared. Okay, in this, they're asking if it's an odd or even function. Okay, even function are symmetrical to the x-axis. It will look like that. Odd functions are symmetrical to the origin, so it will look like that. Okay, so, well, how do you find symmetric to the y-axis? Same thing we did, remember? Last section or yesterday. So all we're going to do is we're going to plug in negative, replace CC and x. So when I do that, I get negative x times 4 minus negative x quantity squared. And if this turns out to be exactly same as the original equation, then it's symmetric to the y-axis. If it's symmetric to the y-axis, then it's an even function. And if you clean it up, this gives you a negative x times 4 minus x squared, because that negative will disappear here. So that's not the same as this, so it's not an even function. Now, what about an odd function? Well, odd function is symmetric to the origin. And how would you check for origin? We replace both x and the y with negatives. So negative y is equal to negative x times 4 minus negative x quantity squared. Okay, the squaring that makes that disappear. You got negative y is equal to negative x times 4 minus x squared. And of course, when you multiply both sides by negative, they will disappear. So you'll get y is equal to x times 4 minus x squared. Okay, so this is exactly the same as this. So we say this is an odd function because it's symmetric to the origin. So they're all related. Symmetric to the origin, odd functions. Okay, even functions are symmetric to the y-axis. Okay, one last one, and this is section 8. Okay, let's do number 3. Okay, number 3, we're given a point 8 comma negative 15. Okay, and we're asked to find all 6 trig functions. Okay, so first thing we're going to do is we're going to plot the point. Okay, my point is 8, negative 15. So let's call that 8, call that negative 15, and there's my point right there. So we're going to drop a perpendicular to that, and that's my right triangle. Alright, to find all 6 strict functions, I need to know all 3 sides. Right now, my x is 8, okay, my y is negative 15. So I have to use my Pythagorean Theorem, okay. Okay, so we have to find that side, so we're going to use Pythagorean Theorem. C squared is equal to 8 squared plus negative 15 squared. So C squared is equal to 64 plus 225. So C squared is equal to 289. And then C is equal to plus or minus square root of 289, which is plus or minus 17. Since this is the hypotenuse, it's going to be positive 17. Okay? So now we can write all 6 strict functions. Sine of, let's call this angle x. So sine of x, cosine of x, tangent of x. Let's find those 3 first. The other three are going to be easy. Sine is opposite or hypotenuse, which is negative 15 over 17. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now, the next thing we're going to find is cosecant of x, which is negative 17 over 15, and then secant of x, which is 17 over 8, and then cotangent of x, which is negative 8 over 15.